So a sector of a circle is a portion of that circle. So it's a piece of a circle, like a piece of the pie. We want to figure out what is the area of that piece of pie. But before we can talk about the area of the piece, we need to remind ourselves, how do we find the area of a full circle? So earlier in this year, way at the beginning of a circle unit, we sort of did a little bit of a review from some of the things you've learned in the past. One of those things was area of circles. So thinking back, can we remember what the formula is for an area of a circle?
360.
360 is your total angle amount.
Yeah.
So diameter times your radius is, or 2 pi times r, that's your circumference. That's like the perimeter of the circle. That will be important later on, so it's good to remember that. So that's your circumference. What do we notice about that picture? What do we have?
A number. You have a little angle measure.
That's 60.
Sorry, the first one. Worrying about the first one.
Yeah, you have like a little like radius.
Yes.
Isn't it? It's radius times 360.
Radius squared. Wait, no, it's not
So the diameter is 2 times the radius. Radius squared is important. What else do we need? What's our thing that always shows up with circles?
Pi.
So pi times your radius squared is your area formula. So it's pi, which is your 3.14, that irrational number that always seems to show up in math, or always seems to show up with circles. It's one of our universal constants, an important number. That times your radius squared, so whatever number the squared is, that will always equal your area of any circle you have. You just need to know the radius. So for, what was that one?
Put the 6 in there.
The 60?
No, 6.
That's a 5.
So it's like the square, like just like the square, like your radius, or just like the square of like your pi times radius?
Just radius.
Okay.
If we want to square both of them, we put in parentheses. But for right now, it's just the radius. So radius is 5. We can square 5 to get 25. So pi times 5 squared, or this is the same as pi times 25. You can put your little dot in there if you want to put your dot in. Once again, pi is just a number. It's an irrational number, so it's like 3.14159, so on. Keeps going and keeps going. For this and for your state test, you should be able to round just to 3.14 if you want to. So if you want to take your calculator and put 3.14, that's fine. If not, most calculators have a pi button on them. Depending on the calculator, it might be in a different location. Most of them are like right above your caret symbol. If you want to use an exponent, you would hit like caret second or caret 3 if you're like putting it to the third power. So what we can do is we can do pi times 25, and that gives us 78.54. If you put 3.14 times 25, you're probably going to get 78.5, which is still fine, as long as you have like, as long as your first couple numbers are the correct and your decimals are close. That's what I'm looking for. If you use 3.14, if you have to use the pi button, it doesn't change it for me. You should get the right. With this, we want to try to unit squared up because we're talking about area. So anytime we're talking about area, it's whatever that unit is squared. So if we were talking about feet, it'd be feet squared. Or if we're talking about inches, inches squared. Whatever that unit is squared. So 78.54 is our unit squared. So that's our area of our entire circle. Now what we want to do today is we want to try to find the area of just that piece of the circle. What are our thoughts about that? How could we try to find just the area of a piece?
Divide.
Yeah, instead of using pi, do 60 divided by 5.
60 divided by 5. So the angle divided by our radius, I don't really know what that would give you.
I was just trying to throw it out there.
So we know it's the same radius. So we know the total area.
Wait, the total area divided by 60.
Yeah, read that.
So we know the total area is going to be the same. It's going to be that 5 squared times pi. How much of our circle do we have though? 60 out of what? 60 out of 360.
fraction.
So anytime you're trying to find a portion, a piece, and you're trying to figure out how much of the total you have, take out how much you have, divide it by the total, and that'll tell you what your percentage or your portion is. And so 60 divided by 360 will give us our percentage that we have, or our, how much, or our portion, or our ratio. So 60 divided by 360, you can also reduce that down to 1 over 6. It doesn't matter which number, they'll give you the same answer. And then we can plug this whole thing into our calculator. It's 1 over 6, or I think that's the same as the 0.3666 repeating or something like that, times pi times 5 squared. And that'll give us the area of just that piece. We just want 1/6 of that total area. And so what we can do is we can take 1 divided by 6 times pi times 5 raised to the second power, or 5 squared, and that gives us 13.0, round up is, yeah, 13.0, and then units squared. So if we think about it, you need to figure out how much of your circle you're looking for, and then just find the area of the entire circle and multiply them together. And that'll give you the piece that you're looking for. So we are sort of condensed this into a formula on what we did. The area of a sector, the area of just a slice of a circle, is going to be that angle divided by 360, because that's the total, times pi times the radius of your circle squared. So as long as you know the radius and as long as you know that angle, you should be able to find the area of any sector you're given. You should be able to find however many slices of pie from the pieces you have. This is our area that we'll keep coming back to. And now that we have a formula, and as long as you have those 2 pieces of information, it's really just plug and shove. Just take your calculator, figure out what the formula is, type it all in your calculator, hit enter, there's your answer. Find your radius, find your angle, plug it all in the formula, plug it in the calculator, hit enter, you're done. So just showing another example. Our angle is 100, so we know our area is equal to 100 divided by 360, your angle divided by 360, times pi, times your r, or your radius, squared. So I know this whole formula. I can take my calculator and I can plug this whole thing into it. Yeah, you need a calculator. Put them over here. So we can do 100 divided by 360 times pi times r raised to the second power. Hit enter, and your calculator should do all the work for you. So our radius, our area is equal to 55.85 units squared. Once again, it's always units squared because we're talking about the area.
I can just put 3.14, right?
Yes. Yeah. So if you want to, you can just type 3.14 instead of typing in pi. The pi button on those blue calculators, if you look at the caret symbol, it's the symbol right above it, or the number right above it, or not the number, the button. That's what I'm looking for. So you can either hit that button to calculate pi for you, or you can just type in 3.14. It's the same thing, or it'll give you the same idea. Your decimals might be a little bit different, but that's okay. So see if you can try to find the other 3. Use that formula, write down the formula, plug it all into your calculator, hit enter, you're good to go. See if you can find those other 3. All right, what did we find for the first one? What was just your answer?
488.69 units.
488.69.
What if I got 44? What's 44?
Did you type in 3.14? Did you type in pi?
3.14? I think it's easy. I said.
So as long as those first couple numbers are correct and your decimals are a little off, it's probably just the difference between someone who actually hits the pi button and someone who actually types it. Just because someone who actually hits the pi button is going to use longer decimals than just 3.14. It's going to use like the 1.5, so on and so forth. But yeah, that's right. What about the second or the third one, I guess? 32.07 units squared. What? Yeah, so it might change a little bit depending on, it's just really depends. What about the last one? 235. units squared. Good. So this is really simple. It's just using that formula. Find the information from the picture, plug it in the formula, plug it in your calculator, you're done. There's not really, you don't have to think through a lot of algebra. It's just pretty simple, plugging into the formula and checking. Are we okay with that? So, the circumference of this circle is 100 units. What is the area of the shaded sector? What's different about this problem compared to the other ones? The circumference.
I thought circumference of a circle.
So the circumference represents the length around the outside. So 360 is how many angles, or sort of the angle measure of the outside, but the length is like the perimeter. It's an actual measurement compared to an angle measure. So we know the circumference is 100. What are we missing?
Your radius.
We don't have the radius. We do have our angle measurement. We know that's 45. So we have, but we're still missing that radius.
We have like two pieces. Like, can't we like figure out what our radius is, or like do like the like circumference formula? Just like
What's our circumference formula?
it's like rip. It's like pi times radius, right?
It's pi times the diameter.
Pi times diameter.
The diameter is always 2 times the radius, so it's 2 pi r, or 2 times pi times the radius. Same thing, 2 times the diameter, or pi times the diameter, 2 pi r. So if we have that, and we have the circumference, we can solve for that radius. All we have to do is set 100 equal to 2 times pi times the diameter times the radius, and we just need to solve for that radius. Pi and 2, those are both numbers. We can divide by those. We can get rid of them. We just want to get r by itself. So we're going to divide by 2 pi. Divide by 2 pi. So in your calculator, what you can do is you can take 100 divided by 2 divided by pi, and that gives us our radius, which is 15.92.
How do I do that? Like, what do I do? Is 100 divided by 2 times pi?
I would divide by 2, divide by pi. Unless you're going to put 2 and pi in parentheses, when you divide it as 2 separate things. So 100 divided by 2,
And then
And then-
take that divided
and
by
then do another divide by pi. Yeah. Or divide by 3.14, whatever you put in. Because otherwise it's going to multiply by pi in the end, because the order of operations is not figuring out that those are sort of things. Good question. So 15.92 should be your radius. And now that we have our radius, we have all our information, we can put it in our formula. So area is equal to 45 over 60 times pi times radius is 15.92 squared. Add that whole thing, plug it all into your calculator, we can get our answer. That's 15.92 squared. And our total solution of that piece is 99.53 units squared. So even if you're just given a circumference, as long as you can solve for that radius, you're good. Are we okay with this? That's the first thing we're talking about today. So that we're talking about like 2 separate things. So that's like piece 1. We're going to move on to part 2 for today. So area of a sector we're going to sort of leave behind. You can drop that out of your mind for right now. We're going to talk about equations of circles, which is sort of completely different part of circles. Equations of a circle. So just like any other, like lines, quadratics, things like that, you have equations in order to graph them. The equation of a circle is a little bit different because it's not a function. If we remember back in Algebra 1, we learned that functions have to pass vertical line tests, which means if you put a vertical line and that vertical line touches 2 parts of your function at the same time, it's not a function. So circles are not functions, so we can't necessarily graph them like we can with other actual functions like a quadratic, a cubic, exponential functions. But it's still important to know the equation of a circle because it can tell you a lot of important information. but we won't necessarily be graphing them. So, what we've learned is the equation of a, not what we've learned, what I'm going to tell you is that the equation of a circle is x squared plus y squared equals r squared. Where does it seem familiar to?
A squared plus B squared equals C
A squared plus B squared equals C squared, or Pythagorean theorem. Really, the only difference between these two
is the variable.
is the letters. We changed A to X, B to Y, and C to R. So we only changed the letters. Everything else is the same. It's the same formula, really, just variables are different. We just wrote it differently. The reason being, if we think about the definition of a circle. Definition of a circle is from a center to any point on the outside, it's always that same distance to radius. So any point that meets that radius from that center is a point on the circle. Well, if we think about our distance formula and how we calculate distance, it's change in x and change in y. From that center, I change x spaces, and then I change y spaces, square both those sides of my triangle, that gives me my r, which is square. So just like how we solve for distance using Pythagorean theorem, we can solve for any point on that circle using Pythagorean theorem. So Pythagorean theorem and your circle formula are essentially the same thing. It's really how we came up with the circle formula. Are we okay with that for the moment? You won't have to like prove that or anything like that. We just want to know that like Pythagorean theorem was the birth of the circle formula. And so from the circle formula, we can find a lot of pieces of information. Or we can create the circle formula just given a little bit of information. So given a circle, I want you to try to create a circle formula. Well, thinking through my circle formula, I know my circle formula is x squared plus y squared equals my radius squared. So first thing I need to figure out is, what is my radius? Well, from the center to the outside, my radius on this is 4. So I know it's going to be x squared plus y squared equals 4 squared. But 4 squared, I know that, that's 16. That's it. You don't have to solve, you don't have to worry, we're just writing the equation of a circle. Same idea for the typing. I know it's x squared plus y squared equals my radius squared. Well, my radius from the center, my origin, to the outside, is 7. So that's 7 squared is 49. So x squared plus y squared equals 49. Are we okay with this so far? So x squared plus y squared equals r squared, whatever that radius is squared. So this is if your circle is centered on the origin. But through geometry, we've had oftentimes where we've had shapes move, we've had shapes turn, we've had shapes change. So all those different transformations we learned at the very beginning here, translation, rotation, reflection, dilation. Well, rotation won't really change your circle very much. Oftentimes, your circle might move. It might change where it started. So, we sort of have to change our formula to account for that. So it looks intimidating. It's really simple. So if you started from the center, and now you move to a random point hk, in order to get your circle back to that center, all you have to do is subtract h and subtract k, where h is the x coordinate and k is the y coordinate. You just have to subtract h, subtract k to get it back to that center. So, our circle formula is x minus the x coordinate of your center squared plus y minus the y coordinate of your center equals r squared. It's that same formula. The only thing we're doing is we're subtracting that x and y coordinate from our center.
Why did they put H and K in there?
It's just random variables they chose. Mathematicians typically like to stick to the same variables representing the same things. So when you do translations in algebra, H typically represents a change in x, while K represents a change in y. And so these are typically the values they use, so that's why they brought it back. It's just two random numbers that represent your x coordinate and your y coordinate of your center. They just didn't want to have x minus x and y minus y, because that would be confusing.
Like A's in algebra a lot, like there was some kind
Whenever you change the function by raising and lowering it, you either added k or subtracted k. We call those transformations, or translations of functions. So if we were looking at an example of this, the only thing that's different is, once again, we're just still looking at the center of the circle and the radius of the circle. So the first thing I need to figure out, okay, where's my center? So that's a little bit different. Last time we just knew it was on the origins, we didn't have to worry about that. But now I have to find my center. So my center of the circle is at 2, 3. And then I need to worry about what is the radius of my circle. Well, from that point, the outside of my circle, that's 1, 2, 3, 4, 5. So writing the equation, I know it's x minus the x-coordinate, which is 2, squared, plus y minus the y-coordinate, which is 3, for that whole thing. And then this equals r squared, which is still the same as normal. So 5 squared is 25. The only thing that's different is I'm subtracting x from that x-coordinate, or I'm taking away that x-coordinate, and I'm subtracting by that y-coordinate from my center. Are we okay with this so far? The same idea on that second one.
Oh, wait, we're done.
Yeah, that's it. Later in the week, we'll talk about what happens if these get changed around a little bit and how to fix it. That's what we'll do tomorrow. It's going to be school tomorrow. But for right now, this is it. You're just writing the equation. So same idea for the second one. Look for the area, or I'm not, look for the area. Look for the center, which is the -4, 1. Look for the radius, which is 2, and then plug those into the formula. I know it's x minus my x-coordinate squared plus y minus my y-coordinate squared equals my radius squared. But if I subtract by -4, it'd be +4. Yeah. And then subtracting by 1 is still -1. And then 2 squared is just 4. So x plus 4 squared plus y minus 1 squared equals 4. So really you can think about it, it's sort of the opposite. If this is a negative, I need to write a positive. If this is a negative, or if this is a positive, I need to write a negative. It's always the opposite sign. So pretty easy. All you have to do is sort of look for that center, look for that radius, and you're good. Sometimes, often with these questions, they make it even easier than you, or easier for you. Rather than giving you the circle, they just tell you the center and the radius to start with. And they're like, here's the center, here's the radius, write down the equation. So you don't even have to look for it anymore. They're giving it to you. And so same idea, plugging those things in. So x minus the x of my center is -12. Well, I know -12, I need to change that to a +12 squared. And then y minus my y center, which is negative, so it'll be subtract 7. And then I just need to take 9, my radius, square it, and that's 81. So with this, they made it even easier for us by just giving us the center and giving us the radius. We don't even have to look for it anymore. And we just have to plug it in that formula. And then we're done.
For the next one, would we put 0 in there? Or would you leave it as H?
So our center is 0, 0. It's the origin. So we'd either be subtracting by 0 and subtracting by 0. Does subtracting by 0 change the problem at all? So if we had x minus 0 squared plus y minus 0 squared equals 6 squared is 36. How could I simplify that?
X squared plus y squared.
And that's what we learned right at the very beginning. Our very first formula we learned was if it's at the center, if it's at the origin, just put x squared and y squared. And so if you ever see it at the center, don't worry about writing minus 0, minus 0. Just skip it. Good question. See if you can do those other two. And then we'll talk about a little bit on the bottom. All right, if we look at those next two, it's supposed to be less. So we look at these next two, it's backwards. Rather than asking us to write the center, and rather than asking us to write the equation, it's asking us to figure out, what is the center, what's the radius of the circle. So we just have to think backwards. Well, I know it's always minus whatever my numbers are, but if I don't have numbers there, it's just origin. So my center would be 0, 0 for this one. And then I just need to take the square root to get my radius, because I know it's my radius squared. So square root of 49, that's just 7. So r is 7, and 0, 0 is my center. Same idea for that second one. I would know it's opposite of what's there. So this is a positive 5. My x for my center is a negative 5. If this is a negative 8, my y for my center is a positive 8. So that's my center, negative 5, 8. And then just the square root of 196. So square root of 196, we get r equals 14. Awesome. Simple, easy.
Zero, zero looks like a word.
Yeah, I can see it.
Looks like a word about something.
Yeah, let's try to get these last two.
No, it's 2.
What was that? You're on this one? Yeah, let's talk about it. All right. So the first one's asking, what is the equation of a circle with a center at 0, 0 and a point at 0, 6? So rather than giving us the radius, they just gave us a single point on that circle. They told us a center at 0, 0 and then a point at 0, 6. So if I put 0, 6 up here, I know my circle passes through this. So I have this circle up here, something like this, that passes through that point. Can I figure out my radius? Yeah, just have to figure out how long is this. Well, from 0, 0 to 0, 6, that's only 6 pieces. And so my radius would be 6. And so if I needed to write the equation, it would just be x squared plus y squared, because I'm on the origin, and then my radius of 6 equals 36. Are we okay with that one, Amanda? The second one is a little bit harder. So we have our center at, let's see, negative 3, 2. So negative 3, negative 2 puts me down here. That's my center. And a single point on my circle is 1, negative 5. And way over here. So 1, negative 5. And this is negative 3, negative 2. Can I find that radius? Rise or run? What do you mean? So if we think about it, our equation of our circle came from that Pythagorean theorem. It came from that distance formula that we used. So if we find the distance between those 2 points, that'll give us our radius. It's that change in x over that change in y. So we have to think, okay, what's my change in x? Well, I'm going from negative 3 to 1. That's a change in 4. What's my change in y? I'm going from negative 2 to negative 5. That's a change in 3. So I just have to do 3 squared plus 4 squared equals my r squared. I'm going back to that equation of our circle.
Why wouldn't it be negative 3? You're going down.
It is, but because we're talking about length, you can't have a negative length, and so it's just possible. And if it was negative 3 squared is the same as 3 squared, because a negative 3 times a negative 3 is still 9, 3 times 3 is still 9, so it really doesn't make a difference. But good question. 3 squared is 9, 4 squared is 16, that equals r squared. 9 plus 16 is 25, 25 equals r squared, so your r is then just 5. From there, we have our center, we have our r, you could write your equation. And so that last one, you just have to figure out, okay, what is the radius by using your Pythagorean theorem or using your distance formula, whichever method you're comfortable with. And then you can find the radius and you can write the equal equation. So it just adds one extra step to it, but it's not something challenging, it's something we already know how to do.